Why does an El Nino cause global effects? Let's go back to our three-cell model to think about this. If we warm the equator, we intensify the Hadley cell, pushing warmer air further north. This intensifies the strength of the Hadley cell and affects atmospheric circulation worldwide. By strengthening the Hadley cell circulation, El Nino can trigger a range of climate variations, perhaps most notably changes in global precipitation distribution. Take a look at this map and notice the changes in global precipitation patterns during El Nino years. Places that become drier also tend to be more likely to have forest fires. What are some of the locations that become drier during El Nino years? What are some of the places that become wetter? The effects of El Nino and La Nina have several impacts on North America, mostly related to changes in the position of the jet streams, as shown in this image. In Canada, the most notable effect is that during El Nino years, Western Canada has warmer winters, and in La Nina years, cooler winters. In the U.S., precipitation in the West increases during El Nino years and decreases in La Nina years. These changes can have important socio and economic effects. El Nino years also cause global temperatures to be higher. This is because there is more warmer water in the equatorial Pacific. But El Ninos do not explain the warming trends we observed last week. This plot shows global temperature anomalies from 1980 to 2017. Red bars El Nino years, blue La Nina years, and gray normal years. Although El Nino years are consistently warmer, all years are part of the long-term warming trend. In fact, scientists estimate that of the 0.98 degrees C warming that has occurred since about 1850, only 0.07 degrees Celsius is due to El Ninos. Understanding the connections between El Ninos, La Ninas, and global temperatures is important to making predictions about the future as climates warm. El Nino is only one of several climate modes that results in teleconnections. This image provides several other modes, including the Pacific Decadal Oscillation, or the PDO, the Atlantic Meridional Oscillation, or the AMO, the North Atlantic Oscillation, the NAO, and several others. Climate scientists are working hard to understand how global warming could affect these modes, and if the modes intensify or their frequency changes, what will the impacts be? This is a really important part of climate change research.